we know that we get the mass or the vast majority of our heat from where? We do get a lot of heat from the sun. And that says a lot about the sun as a star because it's really far away. Okay, so the fact that, have you ever gone outside and just kind of looked towards the sun, closed your eyes, and you felt like the warmth of the sun on your cheeks? Okay, I love that about spring when it starts to get warm out. So if the sun's way over here, okay, that's not what I want. Sun's way over here, and it's sending actual rays. Okay? Now, we were actually going to make these a little darker. The sun is sending us warmth, and that warmth is landing onto the surface of the earth. Okay? Now, here's the cool thing about our planet. We have an atmosphere. And our atmosphere is actually divided into 5 pretty different layers. All right? But the layer that's closest to us, something called the troposphere, okay, is where birds fly. It's, where planes land and take off. Planes actually fly higher than the troposphere. They fly in the stratosphere. Now, the troposphere is interesting because that is where greenhouse gases hang out. Greenhouse gases create this layer, okay, in the atmosphere about yay high. Okay, for the purpose of this picture. Here's our layer of greenhouse gases. And that's great. Without greenhouse gases, our planet is a ginormous ice box. Okay, it's frozen. Where we live, it's frozen. Okay, there would be warmth in and around the equator, but it wouldn't really, every night it would go down to minus something or other. Okay, days would be warm, nights would be freezing, nothing could survive. Okay, now, what's really, really cool about greenhouse gases, and the reason they're called greenhouse gases, is because they behave the same way the glass does when you build a greenhouse. The whole purpose of a greenhouse, okay, is to actually have a home or a building made of glass. And what ends up happening here is the sun penetrates through, and anything that is inside your actual greenhouse, so any living organisms, okay, so here's some more shrubbery here, all of these living things create heat. They create something called infrared heat. Okay, when police officers or whoever has those infrared goggles, okay, and you see like red for people that are walking around in the dark, it allows you to see things in the dark. Okay, some animals actually use infrared sensory recognition to hunt prey. Certain types of snakes, constrictors. Okay, when I look at you, I see you in all of your color. Okay, I see the structure of you. But when certain animals look at you, they would actually see body heat. Okay, they would know that something was living there. So if you put a dead mouse into the aquarium of a constricting snake, it will not touch the mouse. It won't even recognize it. It won't smell it. It won't anything because it doesn't recognize the heat coming off of it because it doesn't have any heat. Okay, so greenhouses, all living things make heat. So all of these living things are giving off heat. Okay, and if that greenhouse is not there, that heat goes out into the atmosphere. Right? All animals and plants. But with the greenhouse, the glass acts as a buffer. So what it does is it actually creates the heat, but it bounces back and it stays inside the greenhouse. So it could be very, very cold outside, but when you walk into a greenhouse, it's much warmer and more humid. And that's because that glass is allowing heat to come in from the sun, but it's not letting any of the heat escape. It's keeping it inside, so it gets very warm. That's why greenhouses will often have these windows up at the top like this that they can actually open to let some of the heat escape. Otherwise, it gets too warm in there and it cooks the plants. Okay? Our planet is working exactly like that. All living things on the planet create heat. And for the vast majority of that heat, it can go off into space. We lose that heat. Very good example of heat being lost like that is in a desert, because there's no trees or shrubs or a lot of living things to hold on to that heat at night, right? So what ends up happening during the day, it could be 40 degrees in the desert, but at night it goes down to it can go down from anywhere from 5 degrees to below zero. Okay, because nothing is holding on to that heat. It's just dissipating into the air. Now, our planet used to actually dissipate a lot more heat into space. We always did trap some heat. Okay, heat does get trapped, and that's what allows us to actually maintain liquid water on our planet. But here's the problem. With the addition of more and more greenhouse gases, our greenhouse layer is getting thicker. Okay? That's getting more and more gases are going into the atmosphere, and that's thickening this layer. So it's creating a larger amount of greenhouse gas in the atmosphere. And what that's doing is it's trapping more heat into the atmosphere. So not only is heat still coming in from the sun, no problems there, all the living organisms are also creating their heat. Not as much of that heat is going out into space anymore. So it's causing the air, the atmosphere, to be warmer. Warmer air causes polar ice caps to melt. Do you see how all this stuff is linked? You cannot have something happening in the lithosphere or the hydrosphere without it impacting the atmosphere. All three of these spheres work together, okay, to allow this planet to actually function. In terms of the climate we have, in terms of the circulation of water, in terms of the circulation of air on our planet, all of these things work together. It's very, very interesting stuff. Okay, but when we talk about the greenhouse effect, what we're talking about is that thickening of the atmosphere that's preventing as much heat from leaving. Now, what you really need to know here is that as heat comes in from the sun, it does not back off from the greenhouse layer does not prevent any heat from coming in. It still comes in. What it does, though, is it prevents infrared heat from leaving, trapping more of it in the air, making the air warmer. The interesting thing here is that the atmosphere naturally circulates on our planet. It goes from a hotter area in and around the equator, and that hot air actually gets pushed northward and southward so that these areas here actually get some heat. Not a lot. The further up you go, the less you get. But the fact that we have that global circulation, that's pretty okay. Okay, that allows for places like where we live to have more seasonality, to have a lengthier summer. Okay, that's why in the fall, September is still really nice and warm. Even though we are actually moving away in our trip around the sun, we're actually moving away. Is that we've generated all that heat in the summer that some of that heat is still lingering. We've warmed things up so much that heat takes a while to dissipate. Okay? Now here's the interesting thing. They're talking right now about a maximum of about a 1.5 degree increase in temperatures. That's a global goal. Okay? Some scientists predict that if we keep on the way what we're doing right now, it could very well be above 2 degrees Celsius. All right? Just to put this into perspective, in the equatorial areas, temperatures range from about 27 to, 35, 40 degrees Celsius. Okay, if it's 27 degrees outside and if it's 27.5 degrees outside, can't really tell the difference, can you? But a 0.5 degree increase at the equator actually translates to something like a 12.5 degree increase at the poles. So if it's 30 degrees outside versus it being 18 degrees, you would notice that, wouldn't you? Case in point, the other day it was 26 degrees outside. Yesterday it was 6 degrees outside. It was a big difference and you could feel it. So that's why global warming is so scary, in the sense that it's not the equatorial areas or the temperate areas. Florida's still going to be Florida. Okay? Water might be a little higher, but it's still going to be warm there. Where it's going to be very, very drastic is in these polar areas. Okay? Where organisms are not going to be able to actually adapt fast enough to change climate. So that's why we're trying, that's what this Paris Accord was all about, trying to maintain our increase in temperature at 1.5 degrees. Okay? That's way less drastic than 2.5 or even 2 degrees. So it's super important to note here that this is infrared heat, whereas this is solar heat. So solar can still come in, no problem. Doesn't matter how thick the greenhouse layer is. But it's the heat that we're producing on our planet that can't get out. So it's making it warmer and warmer and warmer.